What you're looking at is 4 separate AI agents talking to each other, not one AI agent, like pretending to be a 4. Each of them receiving a task is using HTTP request. After he receives, he think. So actually, if you see here we have agent C. This is a red, it is a agent C, and also this also it is a agent B. They are also like responding the exact time, and then they are giving a result back. And actually this it's called A2A. It is one of the most important AI protocols, and I haven't seen a lot of people like covering in YouTube, or if they cover they like make it more complicated. So let me just show to you why even this it's important, like why this protocol actually exists. So before A2A protocol, what you should do, it is like right now the Claude code cannot connect it to your ChatGPT 4 or something like your ChatGPT 5.4 or maybe Gemini. It cannot communicate with it. It cannot communicate a workflow in NN8. It cannot communicate it. So if you need 2 agents to communicate before like A2A, you have to create a program. You have to create API program or application program interfaces. You have to like create from scratch. You have to create and stitch together a lot of programs, and then let us say you wanted to extend it to another AI agent. Then you have to start from scratch and like create this stitches program, stitches code. It was the pain in the ass. So that is where 2025 April actually Google introduced what they call A2A, and actually it is like your Claude right now can connect into ChatGPT and ask some questions, and ChatGPT can answer back. And also like if there is a problem in the workflow, the agent can somehow notify each other and tell, hey, there's some problem in that agent, we cannot read them, like they can, like it's very crazy. And what I see here, it is like we're gonna get a point that even agent has the ability to fix one of them if it's broken. That is what I'm expecting to get in next months. So that's what problem this A2A actually solves. So what is A2A? It is actually an AI agent to another AI agent. It's just like that. So what they're using, it is what they call a HTTP request. And right now your laptop actually, this is, let's say, your laptop, and your laptop uses always when you wanna requesting some information or some data from the internet, he uses HTTP request, and then server see this HTTP request, server see this and then answer back, like give a response. So that's what actually, and HTTP actually it is a plain text, like it's just a text. But right now we use a HTTPS, so we encrypt this text so no one can read our text. So right now that is what actually it is, and it contains actually this HTTP request. It only contains 3 things. First of all, this HTTP contains what we call agent card. Right now it is like you giving your AI agent about the name, what it can do, the tools it has, like it can scrape, create emails or something like that. And this is endpoint, means his IP address, like where he lives. Actually this is endpoint. And then also we have another thing is of this HTTP actually contains, it is also contains the tasking. A task ID, where this task come from, where to is going it, find the lead is what actually the task is, like all those sort of things, and then the status in progress. And also the third thing, it is what they call streamline. Streamline is actually simple. It is the AI waiting, like to respond, some kind of, let us say, respond in the loop. So here AI send this, the request, and then he waiting, like he gonna wait. Maybe like a time, and then he send this request and see if this guy actually he doing the work, and then this guy answer back after he completed the actual work. So Here it is also where I have seen a lot of people really confused when it comes about A2A and also what we have here, MCB. Actually, MCB, it is I call it a vertical. We have here vertical, and here we have here horizontal. So MCB, it is your AI agent actually interacting with your database, your browser, your file systems, and everything. So, and also it is like a translator. Here we have AI agent that wanted to call some tool. So rather than just exposing the AI agent and giving him, like APIs, what you can do is you just give him translator. That's what actually it is. Translator, and this actual translator is what we call MCB. And MCB takes this request from AI and then, do the tasks. And then after he do the tasks, he come back the request back to the AI. So AI can understand MCB better than anything. So that's what we use. And also that's what actually MCB it is. When it comes about A2A, it's actually different. A2A, it is you are allowing your AI to talk to other AIs and request some information, and hey, if there is a task and this AI agent, there's something broken in his MCB, he can notify this back and say, hey, there's something broken there. That is the talking. So right now you can connect N8N workflow to agent, and then and this agent gives you. And also that A2A, it is actually a horizontal. Okay, it's not vertical like this, it is a horizontal. So AI taking request to another AI and then to another AI and then coming back to the original AI. That is what actually A2A it is. Right now, let me show to you one of the demonstrations I created so you can understand practically what actually this look like. If we come into our terminal, create a new terminal here and just type this command. This command is just the demo to showing you how actually this is possible, and then click. What I right now requested the AI, it is, hey, I am a freelancer, so I am freelancer. Please, can you get me automation or AI automation that makes clients, like the client's pipeline full. We want to automate those client pipeline. We want to automate. So what it does, here we have the orchestration guy. It is the main guy. It's the main AI. It is the one who take the task. So he get the task. After that, he gonna go to the research. In parallel, he's gonna give it this task to the research. Hey, research this thing, how we can do, which kind of tools we're gonna use, and then he gonna give it into the red guy another task, telling him, hey, what are the risks when we create this thing, what are the securities, what we should be paying attention of it. And after those two guys really finish their tasks, what they're gonna do is they're gonna channel their tasks back. If you see here, they are responding, they are responding, getting information, like their response, it has been somehow mixed. But actually here we have another agent, and this what it does also is the one who gonna strategize everything and everything created back and then give it to the main orchestration. That's what actually happening. So if you see here, we have the HTTP request. We have agent A, HTTP request to agent B, and agent C. It is parallel, that's the parallel thing. And then we have here the agent B plus agent C. Also, they are working together because they taking the task as a parallel, and then they giving their tasks back to the agent D. So this is the agent D actually, and then agent D, the strategize, is the one who going to strategize and then give back this result is back to the main orchestration. That's what actually happening. So I hope you get it. If you wanna give those 4 agents somehow a memory they can share and they can notify each other, you can watch my video I created, and I'm gonna put it somewhere here so you can watch it, and how you can give them a permanent memories that they need whenever one of them need to take some information, is just go that whiteboard of that open brain and just know what actually going on in the system.